Hello. Hello. Can you hear me?
Yes, sir, you're audible.
Okay. Thanks. Okay. So before I start today's class, yeah. So let me know what else if you have any doubts, questions, comments on whatever has been done so far. So to recap, we were working on this induction on graphs or induction on combinatorial objects kind of stuff, and we had done a couple of examples in the last class, and also we did a couple of wrong proofs and how one can fall in the trap of the wrong proof. And there was one or two questions that were left to be discussed. So till now, yeah, please let me know if you have any questions or comments.
Excuse me, sir.
Yeah,
I had a question regarding the assignment.
yeah,
A lot of the questions they can be easily solved using induction,
yeah.
but is it fine if we don't? Is it compulsory for us to use induction, or is it fine if we use some other proof method as well?
If you can use any proof method, no issue. Unless,
Okay.
see, if I don't state it correctly, that state it that oh use induction or something, I mean I am fine with any technique that you apply.
Okay, sir.
Okay. Yeah.
Sir,
So
I have a question in general about the course.
yeah.
So, do we have a mid-sem for this course? And if so, when is it? Like, is it like at the end of this month? Because
See again, I don't think there is a midterm this semester. Because so the dean's office has not told us anything, but I can tell you that the last semester that happened, or basically your second year batches, their courses started in sometime like in October, not of September, and it kind of got over in middle of December. And for them, there was no midterm. Okay, so this year, this semester also, I don't think there is any scheduled midterm week or something. So you will have directly an end sem. I mean, this is an unfortunate thing because the midterm is always a good thing to evaluate your situation and all. But that is not there because of this COVID issues, and since we are running late, we are trying to make up as much as time as we can.
okay, sir.
So we don't have any mid sem. We have an end sem. The end sem will be on say 40 or 50 marks. I will take a call on that a bit later. And the remaining of the marks will be divided among the quizzes. Well, not quizzes, the assignments. Okay. Now the assignments are whatever is being done or given to you guys. I should kind of point out. I mean, although it's not something necessary to point out, that you should do them. You are allowed to discuss among yourselves. You are allowed to even maybe. I mean, I know that you might want to take a look at the internet to find out what is the solutions and all those kind of stuff. All of this is completely fine with me. Okay, but what
Sir,
we want is
can,
that you should write it by yourself. It should not be a copy and paste, neither from your fellow students nor from the internet. Okay, a proof, you try to understand it, try to solve it, try to digest the proof, and then write it in your words. Okay, yeah. Somebody was asking something else.
sir, what you were saying, I couldn't hear. On which topic you
No,
were
so
saying?
this is about the whether we will have a mid-sem, and in general, how will the evaluations of this course be? Yes, so the evaluation will have basically 50% or 40 to 50% will be on the end sem. There will be only one end sem. How the end sem will be conducted is not completely determined till now. Hopefully, the dean's office will let us know in due course. There is a chance that it might be physical. You might be able to asked to come to the institute campus and have the exam in class, or it might also happen online as it happened in the case of this last semester. There is no end sem. Sorry, there is no mid sem. Okay. So there will be assignments. There will be something 5 to 6 assignments that will be given, and you are supposed to solve the assignments, write it up, and submit it. Okay, so the remaining 50% marks or that will be divided equally among the assignments. So I expect you to solve the assignments, but I am allowing you to discuss among yourselves. I'm allowing you to check the internet and find out and take help from the internet, take help from the books and so on. Many of the problems that will be given in the assignments are not very hard to find. I mean, many of them you will find it on the internet itself. Okay, but the end of the day, whatever you write, that should be your language. Okay, if I at any point of time find that you have taken or copied line by line or word by word from some place or someone else's and assignment and all, you will get 0 in that quiz, in the assignment. I'm giving you a strict order this one. Yeah, it is unlikely that I will be able to catch it, but if I catch it, and I am actually able to catch it quite a few times, I must say, not for you guys, but for previous batches. In that case, that will not be. So, I mean, I look at it in 2 ways. It is up to you to whether you learn anything from the course or not. It's up to you. Okay, if you want to learn something, you should try to solve it yourself, and try to and discuss with your friends, get the solutions and submit it. But from the point of view of evaluation, if I ever find you copying from somewhere else, then that would be you'll get 0 in that assignment. Okay. So by the way, I should also say that someone or one of you possibly asked that whether this deadline of the assignment for this current assignment can be extended a couple of days more. Now, as such, I don't have any so much strict deadline as such. So if you want to submit, I think this deadline is on 14th, which is when is 14th? 14th is on Thursday. So maybe you can submit it before Monday or something like that, because maybe I will be discussing some of the problems on Tuesday. So it's okay if you submit it by Monday. Yeah, so any other questions regarding the assignments and or the evaluation? Is the evaluation part fine? Are you all, did you get the idea how the evaluation happens?
Yes, sir.
Okay. Any other questions? Academic, I mean, questions related to whatever is done?
Promised.
Sorry?
Sir, in the last class, you had promised that you will share a practice set which would not be required to submit, but we
Yes.
have to solve it ourselves.
Correct. I have, if you look at the web page, there has been, I have put up a link to a whole nice write-up on induction. And they are not only nice write-up, but there is a huge number of problems also. Some of them have been solved, some of them are open. And open meaning they are unsolved. Okay.
Yes, sir.
So you can take a use or look at that particular handout. There's a huge number of ways. If you can understand or figure out those set of questions, that I think that would be, I mean, you would have done enough for induction kind of stuff.
Okay. Yes, sir.
Yeah. Any other questions?
Regarding assignment,
Yeah.
Assignment 1, when shall we, I mean, how we did, how
Yeah,
we
yeah.
did?
I will try to correct them and try to give it back to you as soon as possible. I'm right. This week I'm a bit busy with the correction of the end sem exams of last semester that happened, or the second year batches. I should be, yeah. I'm actually a bit lax in that. I should be able to. I should give you back my feedbacks by hopefully by next Tuesday.
Okay, sir.
Yeah. Somebody else was asking something about assignment?
So question 6 part A.
Sorry?
So question number 6 part A.
Question number 6, part A. In which one? In assignment,
Assignment 2.
in assignment 2. Yeah.
Sir, here if we take one example where we have only 3 vertices, and if we draw only 2 edges,
K colorable, there exists prove that a graph has maximum degree less than or equal to K, then okay, fine. You're there. What are you doing actually? You're trying to give me a counter example, is it?
no sir, I'm just, sir, actually this thing is not getting, this is not following with the example that I'm doing.
This is not following. Okay, what is the example? I mean, so that's a counter example that you're saying.
Yes sir, so the, sir, here we have to prove it only, right? We don't have to disprove it.
No, I mean, maybe I've given something wrong.
Yeah. Sir, so the example is, sir, we have 3 vertices.
Let me
and there
share
is,
my screen. Yeah, can you see my screen?
yes sir,
Yeah, there are 3 vertices,
and only 2 edges.
only 2 edges.
Sir, here the maximum degree is 2,
Maximum degree is 2.
but sir, it is 2 colorable.
Yes.
But sir, according to question, it should be K plus 1 colorable.
Yeah, I mean, okay. So if you look at this proof, okay, it says that it is K colorable if there exists a function, right? So basically, if you can color them with K colors, that doesn't mean that you cannot color them with less than K colors. Okay. It is K plus 1 colorable. This graph is K plus 1 colorable, meaning you can color it with K plus 1 colors. That doesn't mean that you cannot color it with less than K minus K plus 1 colors. Is it clear?
Yes sir.
Okay, so I mean, if so in this example that you have told, yes, you are right. It is colorable with just 2 colors, right? Say red here, and you can put say blue here. This is 2 colorable, but I am just saying this is 2 colorable. Okay, so this graph is 2 colorable, but it is also, 3 colorable, right? I mean, 3 colorable just says that you can color it with 3 colors. Doesn't mean that you have to use 3 colors. I mean, you have at most 3 colors. Okay, so see, look at this thing. A graph is K colorable if there exists a function from the set of vertices to 1 to K such that this happens, right? The no 2 adjacent vertices have the same color. Note that this mapping need not be onto. This can be that there are some particular color is not even used. Right?
Right.
Okay.
And sir, there is one doubt regarding the Ramsey problem.
The Ramsey problem. Okay, so Ramsey problem, this one, right? Number 3. I will actually kind of explain this Ramsey problem today. I will go over this episode.
Okay. Sir, because if we take the example of, sir, because this sign is, sir, is it correct? Less than equal to first part. Okay. So because I think it should be greater than equal to.
No, it is less than equal.
Okay. Yeah. So because if we take the example of R of 2, 3.
I will let me do that and then I will.
Okay.
Have a discussion. Yeah. Any other questions? Questions, doubts? Nothing? So you guys have gone over the say tournament problem?
Yes, sir.
You have all gone over the tournament problem? Okay. So let me give you a question. Okay. So here is it. Can you see my thing? So I have a, so this is something that you have not seen possibly. I have a house which total width is 2 to the power k, or say 2 to the power k feet. Okay, 2 to the power k unit. Okay, so 2 to the power k by 2 to the power k unit is there. Is the length of my house. Except that 1 unit here is not there. So basically you can think of it that I have this part. Okay, so this 1 unit is not there. Okay, now I want to cover this whole thing using tiles of this form. Okay, this is exactly this tile. So it is, I mean, 2 feet by 2 feet, or 2 unit by 2 unit, and this is like the L shape. This 1 unit is not there, right? This is one, and this is 1 feet, and this is also 1 feet. So is this tile clear? What kind of tile is this? I have this L-shaped tile. Okay, so L-shaped tile. I want to cover the whole. So basically the question is that, can I cover the whole floor with these L-shaped tiles? Is this problem clear? Hello?
Yes, sir. Problem is clear.
Everybody understood the problem?
Yes.
Okay, so can you now try to solve it right now? And let me, if you have some solutions, you can send it to me by chat. Else I will basically maybe call out some names and then we will try to see. So let me give you a couple of minutes to think about it, and then I will start asking you some ideas. Okay, so I'm getting some, I got some people are writing to me, but so let me call out some names. Vikas Gupta. Vikas Gupta, are you there?
Yes, sir.
Can you um, how are you trying this to solve this problem?
Sir, I am taking the value of k as 4 and try to fit the with the bit
You're trying to take
on
the
that.
value as 4, k equals to 4,
Yes, sir.
and then trying to fit it.
Yes,
Okay.
sir.
But even if you do that, then what will you get?
Sir, I find a small square uh, like 4 by 4
Hmm.
and want to prove want to fit the cube.
No, okay. So let's say you manage to prove it. After that, how will you do? That is
Sir,
not the
first,
end of, that is not the
sir,
end of the.
the base case I will choose.
Okay, fine. That is the base case, and then I mean the 4 by 4 base case. Okay, fine.
Yes, sir.
After that, I mean, other than the base case, do you have some other plans?
Sir, then assume for a value of k induction hypothesis,
Hmm.
then prove for k plus 1 value for.
Why are you doing the base case as k equals to 2? Why not k equals to 1 as base case?
Sir, bit size is 2 by 2.
Yeah,
So,
okay. In the case of 2 by 2, then that is trivial, right? So it is actually this is the actual thing. It's 2 by 2. So the base case will be obvious.
yes, sir.
Then no, I mean, see, I mean, this is something that maybe some of your you have learned it from your from other earlier things that you have to do base case as k equals to 1, k equals to 2, and k equals to 3, kind of stuff like that. There's no such need for doing that. Depending on the induction, we know how many base cases are there. If you are using the fact that something that say pk implies pk plus 1, then 1 is enough for a base case. You don't need 2 for a base case. So just, I mean, just for the heck of it, trying to prove that a 4 by 4 matrix of this kind, right, can be partitioned using a L-shaped tile, that is actually quite useless, because then you are actually spending a lot of time doing something not very exciting. Okay. And I don't know whether that will give you a much idea about this. So let me ask some more people. Shayan Shaha, or just one thing, maybe before I go, Vikas Gupta, are you an MTech student or a PhD student?
Sir, MTech CS.
MTech CS student, right? Okay, fine. Okay, Shayan Shaha, are you there?
Yes, sir.
Yeah. How are you approaching this stuff?
So, sir, for if you take the base case as k equals to 1, and so you have a square floor of size 2 cross 2, right?
Yeah.
So, and you have this L-shaped tile. So you have like 3 grids, and like one grid remains empty, right? So you cannot use L-shaped
See,
L-shaped tile to cover.
again, base case
Yeah.
You are saying that K equals to how much? 2 or 1?
1.
So then how is the floor?
Yeah, so it's a 2 cross 2 floor.
It's a 2 cross 2 floor with the last one gone, right?
Oh, so it's not a square floor. Okay, then you can just.
I never told it's a square floor. I told
I
it's a
did
square
not see
floor.
this. Okay.
You
I did
didn't
not
see
see
this. I
Oh,
have
I did
spent
not
quite
see
some
this.
time on that.
Okay. So sir, you can. So the base case is done. Then if you assume that say for k minus 1.
Yeah.
That is your assumption that you can cover the cover a 2 to the power k minus 1
Okay,
grid
so
with tiles like this.
PK is basically, you're saying that a floor of size 2 to the power k cross 2 to the power k can be covered. A floor, maybe I could put a floor star because I mean the floors
Yeah.
are like this without this
Yeah.
one. Can be covered using L-shaped tiles.
Yeah.
Okay, so this is my induction hypothesis.
Yes.
Okay, so what is induction hypothesis? Induction hypothesis is PK is true. Okay, so let's say PK is true for any k less than or equal to n minus 1. Okay, and now?
Yeah. So so pk plus 1, which is a floor of size of 2 to the power k plus 1 into 2 to the power k plus 1. So you can like think of it as attaching another L-shaped tile to this floor of size 2 to the power k into 2 to the power k. So and you know that you can you have your base case, which is like you can cover.
I don't get it. So see, this is so the L. So you have P. You have this. This is how much you want to do it for PK minus 1. Okay. So this is 2 to the power k k and 2 to the power k, right?
Yeah.
And 2 to the power k. And what you are trying to do? Where you are applying the L-shaped tile?
So
the L-shaped tile is of size only
2 cross 2. Yeah.
2 cross 2. This is 2 cross 2. Now you are trying to produce a 2 to the power k plus 1 cross 2 to the power k plus 1 floor using this and the L-shaped tile.
Yes, sir. So if you attach this in this gap, then you get a 2 to the power k plus 1 into 2 to the power k plus 1.
In this gap?
Yes, sir. Yes, sir.
How? I mean, this is a 1 bit. So you mean this kind of stuff?
Oh, that's the one.
So in the last class, I spent a lot of time on one thing. Do you guys remember that? I had worked a lot of times on one particular thing.
Sir, you told that when we need to prove on combinatorial object, we have to start with the specific instance.
Exactly. You start with the specific instance and not just this thing. Okay. This is something I have spoken a lot. So here,
and that point actually we missed a lot of time. I also realized that we missed a lot of time that point.
Yeah. So are you a PhD student or a MTech student?
GRF.
You're a GRF student. Okay. So again, I am repeating once again. This is something that is very, very, very essential. You start with writing what to prove. This is important. What to prove. Now, what to prove here? We have to prove that P, I mean, like maybe since you guys was working on this PK, okay, so let's do it with PK, okay? So induction hypothesis, PK is true, okay? Then prove that PK1 is true. Show that PK1 is true. What does it mean? you start with a square, okay, of size 2 to the power k plus 1. This is very essential. You don't start with the square of size 2 to the power k and try to create a square of size 2 to the power k plus 1. You try to start with the size of square of size 2 to the power k plus 1. Okay. Shayan, is it clear?
Yes, sir.
Were you there in the last class?
No, sir.
Why not?
Sir, I was back in my college correcting my degree, so I could not attend.
Okay. You did not follow the do the videos on the YouTube also.
No, sir. I will.
Yeah, I mean, this is, I mean, it is not very helpful if you guys miss this stuff, because I mean, we are putting a lot of effort, particularly in this COVID situation, so that we are able to reach you with all the necessary instructions and then all the necessary teachings and all. But if I don't get a proper response from you guys end, then not only are you not gaining anything, I mean, you are just thinking of ISI as just a place to get another degree. Also, you are kind of demotivating us quite a lot. And see, I mean, one thing that you should also remember this one, that ISI is a bit different from the other colleges that you have been possibly. Our primary job is not teaching. Our primary job is actually research. Okay. So we do teaching because we do like teaching. We want you guys to know something, and that's what we are doing. Yet. But if we find that we are teaching to a group of people who are not interested in learning, then that's all that will happen, is that it will become demotivated. And we will be least concerned about whether you have learned something or not. So, I mean, this is a mindset change that you have to do, that in ISI, if you have just come to get a degree, then I think you have come to the wrong place. And if you have come to learn something, we will be more than happy to explain you 1,000 times, both simple concept and advanced concept. But you have to show something back from your side. If I am taught, if I don't get that response, I mean, I feel demotivated and I will just be losing interest in teaching. And that will not be a good thing for, I mean, any one of you. Okay, so let's go to someone else. Animesh Pal, are you there?
Yes, sir.
Yeah, so do you have any idea of how to now proceed from here?
If we assume that 2 to the for 2 to the power k is true,
yeah,
then we start from 2 to the power k plus 1 box, and then try to delete so that we get 2 to the power k box.
Yeah,
delete some part of this.
How can we delete to get it to the power k box?
Sir, in the both part is 2 cross 2, two sides to delete from this row and column as well.
Size 2.
And then we.
Okay, by the way, if I delete 2 sides, 2 unit from here and 2 unit from here, how much do I get? If I give 2 unit from here and 2 unit from here, how much is this the new one? What is the size of this new thing? What is the size of this new thing?
it is 2 to the power k and 2 to the power k.
Okay,
Oh,
let's see. 2 to the power k plus 1 was this size, right? From that I'm removing 2. So I have minus 2. Do you think this is equals to 2 to the power k? Hello?
sir, no, sir. So 2 to the
No.
power
What is this quantity?
2 to the power k by k plus.
This is 2 to the power k by 2? No. Think of k to be equals to 10. Right? 2 to the power k is equals to 1024. 2 to the power 10. Right? So you are saying that let's subtract 2 from it. This is 1022. And if k equals to 9, then 2 to the power 9 equals to 512.
512.
Is this equals to 1022? So how do I get from 2 to the power k plus 1 to 2 to the power k?
Sir, subtract 2 to the power k.
I subtract 2 to the power k. That is true. So I have to subtract 2 to the power k from here. Let's see, let's try to do that. I subtract 2 to the power k from here. Now this is a huge number, 2 to the power k, and this is 2 to the power k. Now what? That's a massive number. I agree. Then what happens here? Then this chunk is actually also 2 to the power k. This chunk is 2 to the power k. So this square does look like the square which is for the, what will happen for the 2 to the power k plus 2 to the power k minus a square at the end, right? So let me call these numbers as this squares as, by the way, subtracting 2 to the power k is same as, by the way, instead of this way we can think of it that 2 to the power k plus 1 divided by 2. So in some sense I split up into 2 halves. This is 2 to the power k, this is 2 to the power k. This is also 2 to the power k, this is also 2 to the power k. So I partitioned the 2 halves, and now I have 4 things, A, B, C, D. Now this A, let's just look at the A thing. Can this A be covered using the L-shaped tiles? Avanish Kumar, are you there? Okay, you have, hello?
Yes, sir.
So you have got it, right? I see that you have also chatted with me.
Yes, sir.
You have got it fully? I just
Yeah,
asked.
yeah.
Okay. Okay, then let me go to somebody else then. Okay. Mohammad Azad Ansari.
Yes, sir.
Yeah, so you have chatted with me by saying just yes, you can. But have you got this solution completely?
Not completely, sir.
Not completely. So here, at this point here, can you say something? Can this 1/4 of this thing, this 2 to the power k by 2 to the power k, can this be covered using L-shaped tiles?
Yes, sir.
Why?
Using base case.
Using base case? Why is base case working? See, base case only says for 2 cross 2, not for 2 to the power k cross 2 to the power k. So do you understand? So what is base case to you? Hello?
K equal to 1.
Sorry? K equals to 1. But k
Yes.
equals to 1, how can k equals to 1 say anything about general k? So look at it, there are two parts here, right? We have this base case and we have the induction hypothesis. From either of them, do you see how to prove that A can be filled up with this L-shaped tiles? Hello?
Yes, sir.
No, I mean, do you have some idea that you're just blanking out?
No idea, sir.
No idea. Are you solving the assignment questions?
Yes, sir.
You are managing to solve the assignment questions? The second
Yes, sir.
assignment?
First.
The first assignment you have done?
Yes, sir.
But what about the second assignment? I mean, technically it was due only in 2 days' time, right? It is
Yes.
due on Thursday. Did you manage to solve any of them? Don't worry. See, yeah, go ahead.
I will do, sir.
No, it's not about you whether you will do or not. I'm just asking whether I can help you in some way. If you are struggling in understanding it, that is completely understandable. Okay. You have to inform us that, see, I am struggling a bit, or I am unable to solve them. I've tried and could not do it, and we will try to arrange something for you. This is a statement to everybody of you. I can see that many of you are struggling. Either you guys have kind of dropped out of the course because of this, or are not able to follow it from some other reasons. I have no idea what was this thing, but so many of you are struggling. Now, struggling is not your mistake. Okay, if you are struggling, if you are unable to cope up with the class, if you are finding the class to be going fast, okay, you have put in some effort but still unable to understand or keep pace with the class, all I am requesting you to tell us that I am struggling, I am not understanding this concept, or any of these things. You don't have to openly say it in public. You can send me a private email. And for you guys, I will be happy to conduct extra classes. I can happy to ask the TAs to work with you guys, because this is some basic stuff that we are talking about. And if we are stuck in this level, then the rest of the time in ISI will be a painful time. Believe me, this is okay. So we need you to be with us. Let me ask you, how many of you have not been able to how many of you think that you are struggling? Can you just send me a private chat? You don't have to send it to everybody. That I am unable to understand this problem or something like that, or I could not understand I don't know how to finish this problem. Because right now I have told you guys a lot. At this point of time, I expect you guys to be able to solve it. So can you please send me, whoever has not got it, can you send me a chat that I have not got it?
Sir, excuse me, sir.
Sorry, yeah.
Excuse me, sir.
Yeah, tell me.
Sir, I could not hear last 2 lines. Can you please repeat it?
No, I'm saying that if you have not been able to solve this problem, this particular problem till now, okay, then
So the
can you
square
just
one.
send me a chat, private chat that I have not been able to solve it.
So the square one.
The square one, yeah.
L-shaped tile.
L-shaped. Yeah, I mean, I'm getting some of you are sending it, and I'm very happy that you guys are telling it. Please tell me, as we will not be able to understand where we stand. Yeah, I can give you the solution. The solution is just literally one line from here, and people who have got it will vouch that once whatever I have done till now, from there it is like an obvious statement. But if you are unable to get it now, or if you are struggling to follow it, please let us know. Okay. Let me have a quick poll. Okay, just one second. Let me just stop my share once and have a quick poll. Okay, I'm putting up a poll. Please answer that. I can see still there some people have not submit, they've not told, not given their answers on the. Hello. There are 37 of you. I think one of them is a TA. Then there should be 36. So 3 more people have still not given answers to this, to the poll. I please request you to do that. Okay, I guess that then there are 3 people who are just have kept their things on and have gone off. I will be able to find out by looking at the polls. Okay, so if I understand it correctly, there are 8 of you who have still not got it or are struggling or have got it but have not followed it. I mean, they have got it but still. Okay, so I can, the people who have clicked on I still did not get it, and the people who have clicked on I get it now but still am confused about some of the steps. There are 8 of you. Can I please request you to send an email to me personally with an head just saying that I mean I am struggling a bit over here. Okay, this is something that is very, very, very important because I will be happy to can talk to you guys individually and understand what is the situation. Okay. Just 1 second. Chandrima? Hello,
Yes,
Chandrima, are you there?
Yeah.
Can you see the chats?
Yeah, some of the chats. Hello?
You cannot see the old chats, right? The other chats.
Actually, the chat they have sent to everyone that I can see.
Okay. Okay, sure. So Kaushik Pati, you have asked me something I don't understand. Is it okay, sir? What does that mean?
Sir, earlier I have sent another
Yeah,
chat.
so about this divisible by 3 or not?
Yes, sir.
Okay. Yeah, so okay, so let me just give you the proof of this one and that will help you to understand it. You don't need any of those kind of stuff, whether it is divisible by 3 or not. Okay. Yeah, so whoever has think that the induction concept is not clear, whoever wants to have needs some help about this induction or have not been able to solve this problem even now or are confused with many of the stuff, please write a mail to me. Okay, please, I can request you because this is not a I have another question. I mean, before I kind of do this one, since I started this polling thing, I want to again know how many of you are MTech and how many are free at JRF? Okay, so it seems that the number of MTechs have not increased. In fact, if at all it is, I mean, lower than what was there last class. So I don't know what is going on, but please pass on the information that if you are struggling, to let us know. We might have to have some individual one-to-one sessions with you guys to help you guys understand this stuff.
Hello.
Yeah.
Sir, actually, I am facing problems with two-dimensional induction, where we take.
This is not two-dimensional.
Yes, sir. This is not, but actually.
No, I'll come to two-dimensional. Okay, so let's. I understand that you are finding these things are fine, right?
Yes, sir.
As long as, yeah, I mean, two-dimensional and all, we will come to that. But if you are more or less comfortable with the graph inductions and inductions of like this, okay, you are in a good shape right now. We'll come to two-dimensional soon. But I mean, the reason I am actually spending a lot of time on this set of things is that, I mean, without knowing to do induction on graphs, we will just not be able to do anything in this course. Believe me, nothing in this course. Okay, so coming back to this particular question. Okay, so what did we do? We told that there is a base case. Base case meaning what happens if k equals to 1? In that case, floor was exactly like the tile, and it was obvious that the floor can be covered with such a tile. Very good. Then we told that, okay, let's say that the problem that whether a 2 to the power k cross 2 to the power k shaped floor can be tiled using L-shaped tiles. Let's call this one pk. Okay, and the induction hypothesis we have is that, so let's say that pk is true for some k. And now, assuming that pk is true, we want to prove it for pk plus 1. Okay, so what do we want to show? So the instance is that I have been given a floor of size 2 to the power k plus 1 by 2 to the power k plus 1, and I want to tile it with this L-shaped tiles. Note that I don't have to tile it from the beginning. That's the beauty of induction. I just have to tile it. I'm assuming that I know how to tile a k 2 to the power k plus 2 to the power k floor, right? So, I mean, what does this mean? pk meaning we know how to tile a 2 to the power k plus 2 to the power k floor. And again, when I mean floor, I mean 2 to the power k plus 2 to the power k, this kind of floor, okay? A floor with this is very important, with the one removed. Okay? Good. Now, I start with this 2 to the power k cross 2 to the power k, sorry, 2 to the power k plus 1 cross 2 to the power k plus 1 floor with the top one removed. This is my instance of 2 to the power k plus 1. Then I want to bring in this knowledge into my proof. What does it mean by this knowledge into my proof? So what I do is that I split up, I observe that if I take 2 to the power k plus 1 and divide by 2, that means I kind of have a partition of this whole floor, both the length and the width into 2 equal halves, right? Then I have a 2 to the power k cross 2 to the power k, right? So this is the 2 to the power k cross 2 to the power k floor. This is the 2 to the power k cross 2 to the power k floor. This is the 2 to the power k cross 2 to the power k floor, and this is the 2 to the power k cross 2 to the power k floor. But now, do I know how to tile this? No. Why not? Because I know how to tile a 2 to the power k cross 2 to the power k floor only if the top one is removed, only if there is nothing here. But this is a completely square floor. I don't know how to tile this. But do I know how to tile this? Note that this one is actually a 2 to the power k cross 2 to the power k floor with the top tile removed. This is exactly what the induction hypothesis says, right? So by induction hypothesis, A can be tiled. Is this clear so far? So I have been able to tile up this part. Is this clear? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Now I need to come up with a tiling for the rest of them. I don't know how to tile it by induction hypothesis. But here a small trick is required. So what do? I say, let me use a different color, maybe green color. I put a tile over here. This is a single tile. Do you see it, this tile? I can do that, right? So then this one B, so B minus what have been covered by the green. How does this look like? See, when you tile something, it doesn't matter how you orient it, right? If I can tile a square like this, I will also be able to tile a square like this. I will also be able to tile a square like this, same size. I will also be able to tile a square like this, right? It doesn't matter how I tile it. So B therefore looks very much like A. This is the square with one tile missing. So in that case, B minus one tile can be tiled again using induction hypothesis. Similarly will be the case with C minus this one tile. And similarly will be the case of D minus this one tile. Okay, so what did I do? I use induction hypothesis to tile A, then I tile B minus this green tile, then I C minus this green tile, and then D minus this green tile, and in the middle I put this one single tile over there. And that helps me to tile the whole space. So I managed to prove that even D minus one tile and D minus one tile can be tiled using the induction hypothesis. And so overall, I have managed to produce a tile of size of the whole space of 2 to the power k plus 1 plus 2 to the power k plus 1, which means that pk plus 1 is true. So I have got base case, I have got the induction hypothesis, and using inductive step I prove that if pk is true, then pk plus 1 is true, and that will help me to prove the whole structure for all of them. Is this clear? Whoever was struggling?
Yes,
Yes,
sir.
sir.
Clear now.
Yes, sir.
Kaushik, are you now comfortable with that? The fact that you don't need anything divisible by 3 and all? Kaushik? I think Kaushik Pati was the name, right? Hello.
Hello, sir.
He has gone.
Hello.
Yeah.
Sir, this solution is fine, and after that, you have given some hint. I would come to this point. But sir, initially, what I thought that I assumed that we have to show pk plus 1, and what is pk plus 1 is 2 ki power k plus 1 into 2 ki power k plus 1. And when this can be rewritten as 2 ki power k into 2 ki power k into 2 ki into 2 into 2. So we know that 2 ki power k into 2 ki power k is pk, and that is also true. And 2 into 2, that is our base case, that is also true. And sir, like that we can conclude this pk1 is also true, sir.
I mean, you are starting with 2 to the power k and producing 2 to the power k plus 1, right? That's what you are saying.
Yes, sir. No, sir. Like that we have to show 2 ki power k plus 1 is true.
Yes.
So I am starting that 2 ki power pk plus 1 is equal to 2 ki power k plus 1 into 2 ki power k plus 1.
Right.
And and that can be rewritten as 2 ki power k into 2 ki power k into 2 into 2.
Okay.
And we know that 2 ki power k into 2 ki power k is pk. That is true.
Right.
And 2 ki power and 2 into 2 is our base case. That is also true, sir.
No, I don't understand how we are concluding from that.
Yes, sir. That's what I'm initially thought, sir.
You cannot multiply two objects just like that, right?
Yes, sir.
Say again. I repeat it again. Like I last time told you, and I hope that I don't have to say it again, but I am sure I have to say it. In induction, okay, the simplest thing is to not think much and say that start with an instance of the pk plus 1. How does the pk plus 1 instance look like? Start from there. Don't think too much. Okay, and then try to massage it, break it in some form to produce instances similar to the instances of pk. Don't try to go in the other direction. Don't, because that is something a complete, no. If you do in the other direction, you are almost certain to make mistakes in this combinatorial induction cases.
Okay.
Don't do that. Just don't try to argue with yourself in this thing, okay? And if at all, I have given you these 2 proofs of wrong statements using induction. Just go and think about it. Okay, and then see what happens there. Okay.
Sir, here just one small doubt I have.
Yeah.
Sir, in the question, in the question itself k is mentioned, then can we use variable k here in the solution? Or
no, that is the writing stuff. Yeah, it doesn't matter. Maybe I would have not used k, I would have used n or something. But that's okay. This is like something more like you should not use the same variable to indicate 2 things in the proof, else there can be a mistake there. But we often do that. That's a mistake that we do, and we should not do that. But yeah, a good writer, a good proof writer would not do that. Okay, so usually what I do is that I personally use ijk for indices, and here I always think of it as that I usually, if I was there, I would have written that pk is true for all k less than or equal to or strictly less than n, and I would have proved it for Pn. Okay, so this is what I would have done, and I had proved it for Pn. But yeah.
Hello, sir.
Yeah.
Actually, sir, I have some other approach and I don't know it's right or wrong. So
Okay.
can I?
Sure.
Okay, sir. Here we can make, sir. Here we can build a smallest block would be of size 3x2 using two L size tiles, and after that, so if we have to cover the whole floor, to 2 to the power k into 2 to the power k should be divisible by 3x2.
Hold on. So you are saying that first you will make a tile
yeah,
of this form.
Yeah.
And why is it 3x2? Okay, 3 like this.
Yeah.
Okay, fine. You do that.
And so for that complete that covering the whole floor.
Okay.
2 to the power k into 2 to the power k should be should have it should be divisible by 3x2.
2 to the power k into 2 to the power k. Why?
Yeah, sir. The size of the whole floor.
Why should it be divisible by 3 into 2? I don't understand.
Divisible by 3x2.
Divisible by 3 into 2.
Yes, sir.
Why?
Because, sir, that's how we can like make a that's how we can cover the whole floor.
No, but first of all, you realize that 2 to the power k cannot be divisible by 3.
Yes, sir. That's how we can prove that, yeah, 2 to the power 2 to the power k and 2 to the power k is not divisible by 3 into 2. So we can like conclude that like it's not possible.
I mean, what is not possible? Are you trying to conclude that it is not possible to tie it?
Yes, yes, sir. Yes, sir.
But I have just proved that it is possible.
Then, sir, what's wrong in my solution? Like,
first of all, because this is not that. First of all, there are two parts. Okay.
Okay. Okay.
A tiling doesn't have to be in blocks.
Okay.
It can be completely different. In fact, the actual tiling will not be in blocks. Okay.
Okay.
In fact, the actual tiling, first of all, right, will be how much? If you like unfold it, it would be like this. Okay. And then there will be somewhere in the middle. And then there will be, so this is like this, say let's look at this one. Okay. One. Okay, so this is a 4x4 tile, right?
Okay.
How will the tiling be? It will be like this. It would be like this, like this, like this. Something is wrong. I have not done something right. What didn't I do right?
Sir, the top right, you have done some means.
I have not drawn it rightly, right? Something. Sorry. Okay, right. So this should be not like this. It should be like this. Now, right? So this is the 4x4.
Okay.
So it should be this and this. Okay, this is the actual tiling of the 4x4 minus 1.
Okay. Okay.
And there is no, this structure is not there.
Okay.
Okay.
Yes, I got it.
So you cannot assume that a tiling will always have a structure like this.
Okay.
If it might not have any structure like this. First of all. Secondly, when you have a missing structure over top, right? Then how can you even talk about this divisibility and all those kind of stuff? The closest that we can talk about is this problem, okay? That 2 to the power k, how many squares are there in 2 to the power k plus 2 to the power k?
Yes.
2 to the power k into 2 to the power k minus 1, which is 2 to the power 2k minus 1 is the total area of this space.
Yes.
And if this has to be divisible by this triangle, this kind of objects, right? This L-shaped stuff, then these L-shaped stuffs have the area of, so area of square is this. area of L-shaped tile is 3. So if at all it is possible, 3 must divide 2 to the power 2k minus 1.
Okay.
And that actually does. You can think of a number theory, it does. But this is not again good enough. Just because it divides doesn't mean there is a tiling.
Okay.
If it did not divide, then it would have meant that it is not possible at all.
Okay.
Okay.
Okay, sir.
But okay. So I mean, yeah. So when so in this course, in general in any theoretical computer science or discrete mathematics courses and all, you should kind of always not assume certain things. Just, I mean, the tiling means that you have to tile it in terms of blocks and all. No, there can be any possibility is possible.
Okay.
Okay, so that is something that you should not forget. By the way, so I mean, so you are a JRF or a MTech student?
I'm tech, sir.
Okay, and did you, when you replied to this stuff, this quiz, and this the question that was asked, this poll, did you say that you have managed to solve it or not solve it? Hello? Hello?
Hello, sir. Are you asking to me?
Yeah, I'm asking you. So when
Yes, sir.
what did you answer when in the case of the poll? Did you follow it or not follow it?
Yes, sir. Follow it. I completely understood like what you said.
You completely understood what I said? Which said? What did I say?
What, sir? What you said?
Just now?
Yes, sir.
And the proof?
Yes, sir. Also.
You understood the proof and still you are not convinced that you are trying to prove that it is not possible to tile it.
No, sir. But yeah, like I find out my mistake. Yeah, I was wrong there. In my solution.
Okay. Okay. Okay.
So can we use diagrams in formal proof?
I mean, see, diagrams are kind of a useful thing to understand the intuitions and all those things. Okay. So here, I mean, like for this kind of stuff, if you use some diagram, that's fine, perfectly fine. Okay, as long as the actual thing is formal, we are fine.
Sir, in latex, sir, it will be very tough.
You can just write it, draw it in a piece of paper and then take a photo and upload it as a JPEG or PNG.
Sir, my question is that in this particular solution that you have provided,
yes,
sir, if suppose we would like not to use diagrams, so is it possible to prove this without diagram, just by statements?
Yeah, you can actually. You can. I mean, you can. These are coordinates, right? The coordinates. There are coordinates here. Like this is the coordinate of 2 to the power k by 2 to the power k, kind of stuff like that. You can think of that. Okay, I will put a thing. I will place it in such a way that the x-axis and y-axis lines up like this, and this is this 0. This is the origin, and I will place a tile right at the origin. Okay. But if you think that drawing something is useful, then you can feel free to draw it. Okay. Feel free to draw it, and you can just take a photo and use and upload it in the LaTeX. Okay, so where were we otherwise?
Sir, another thing.
Yeah.
When we are writing in assignment or in exam anywhere, the diagram for this type of proof, is it compulsory?
No, nothing is compulsory. Okay. I mean, you can see the job is to write it, give a formal proof. Formal meaning there is no loopholes. There is no vagueness. Okay. A diagram can also be a formal proof. Okay, a formal proof is not something that, I mean, here there's no question of this picture, has no question about I don't say, oh, keep on doing it and you will be able to fill it up, right? I have given you a very solid way of tiling using the induction stuff, right? So formal proof is something that there is no loophole, there's no ambiguity. And you can do it, give it either by drawing a picture or by writing it in words, either of them is fine. Okay.
Okay, sir.
Okay, I think so. I thought that I will do something about this code. About this Ramsey number part. Okay, but let me just tell you one thing before I can go ahead. I mean, I think I will not do this one today. In the Ramsey number, just this is the first part. Okay, this first part is actually an induction on. It's not an induction actually. First part is not an induction. It's an argument in the graph theoretic regime. Okay, so this is no induction. This is an argument on graph theoretic regime. Yeah. Okay. Oh, so somebody had pointed out that this one, right? Why is RP1 equals to 1 and R1Q equals to 1? Because maybe there is a mistake over here. Any n people there exist? Few of them who know each other. It's truth. Yeah, actually, this is a slightly wrong, I think. Anyways, I will not. I will leave it to you. But anyway, so forget that. So this is one part, okay? So this 3a is a part in the graph theoretic argument. Even if you cannot get that part, it's fine. Okay, but I mean, we will discuss it again on Friday in any case, before your end of the assignment. But other than that, this second part is actually an induction where the recurrence is given on the top. So using this theory 3a, you should be able to prove 3b. And that proof is kind of independent of, okay? The proof of 3b is independent of proof of 3a. You have to use 3b, for proving 3b, you have to use the statement of 3a, and that's it. So for now, I'll be happy if you can just try to solve 3b using the statement 3a and think about this 3a. In Friday, I will go over this statement of 3a and how to kind of prove this statement.
Sir, is it okay if 3b is proved without using 3a?
That also is fine.
Okay.
That also is fine. Yeah, as long as it's the correct proof, we are fine with that.
Sir.
Yeah.
In this Ramsey number, sir, this is it necessary that P plus Q is equal to N?
P plus Q equals to N. No, see, then N is not an given input. No, it is not. It is not equal to N. So basically, think of this way, okay? That P equals to 2, Q equals to 2. What does it mean? What is RPQ? Okay? Okay, so say I give you P equals to, sorry, I give you P equals to 2 and Q equals to 2. Then what is RPQ? The idea is that you have n people, or in some sense, of course, I will draw it in terms of n graphs, okay? So RPQ, let's say I draw a graph of size 3. Okay, yeah. Okay. So I have said right. So I have just say 2 people. Okay. That means I have a graph on 2 vertices. Now, what all possible graphs are there on 2 vertices? You can be either this graph or it can be the empty graph. So there is a graph with 2 possibilities, possibility 1, possibility 2. I claim that either of them, in either case, whichever it happens, either there exists P equals to 2 means either there exist 2 people who know each other. That means either there are 2 people who have an age between them, or there are 2 people who don't have an age between them. Right? So the idea is that if I give you just, if all I need is the number of vertices, as long as number of vertices is more than or equal to 2, then however way I draw a graph, whether I draw an edge or not, you will always either find a edge, okay, or you will find a pair which doesn't have an edge between them. So RPQ is minimum such number. It is 2. So RPQ equals to 2 in this case. What is P equals to 3, Q equals to 2? Say, what it means is that you have to give me a number such that if I draw any graph, then either there exists a triangle. So P equals to 3 meaning there is a triangle, or there is and Q equals to 2 meaning there is 2 vertices at distance, 2 vertices that don't have an edge between them. So the number of such vertices, say if I draw, so if I have RPQ in this case, if I have 3 vertices, then how can you draw, right? Either you can draw by saying that, okay, I have an edge between these 2, or I don't have an edge between this vertex and this vertex. If I don't have an edge between these 2 vertices, then I have my independent pair. But if there is the edge between, if I don't have that, then I have edge between all of them. In that case, I have my triangle. So in this case, RPQ becomes 3. It's the minimum number of. What I mean is P equals to 3, Q equals to 3. That means RPQ, I am asking for that how many can I have, say if I draw 4 vertices, say. Now, is it possible? I can draw an edge like this, right? 1, 2, 3. Note that here, this is a graph where you will not be able to find, this means that it's a triangle. You will not have a triangle, or you don't have 3 vertices like this without an edge, right? So just 4 is not good enough. So RPQ must be more than 4. Okay, what about 5? If I have 5, then, okay, if I have draw a graph like this, then there are 1, 2, 3. 1, 2, 3, then there are edges like this. And if not, what happens if I draw like this? Even then, I have 1, 2, 3, right? But if I have a edge like this, so that means it's a 5 edge, okay, good. So say I have a 5 thing. Yeah, I have 5 things which means here. So this graph, again, with neither do I have a triangle nor do I have a 3 independent set. That means even with 5, I cannot guarantee you that there exists a triangle or a independent set. So that means this RPQ must strictly be more than 5 also. What happens 6? Now you have to go and find out. I think RPQ in this particular setting, now I am not very sure what is 3. It is, I think, 7 if I'm not wrong.
Sir, it is 6.
It is 6? Okay, 6. Good. RPQ is 6. Okay, so you can go and prove it. That means, what do I mean by that? That means if I have 6 vertices, then you are allowed to put edges in whatever way you want between here, like the edge here, or here, or whatever. Okay, there are all total 6 choose 2. That means 15 edges. You can put any of the 15 edges you want, and however you put it, either there has to be a triangle or there will be a triangle always. Sorry, either there will be a triangle or there will be a 3 independent set. So that means at the level of 6 edges, vertices, you kind of guarantee that there exists 3 and 3, or 3 or 3. So that's why this is for 6. So this is basically RPQ is therefore the minimum number n, such that if I give you a graph of size of number of vertices n, however way I give the number of edges, however way I draw the edges, I don't mind. Either there has to be a complete graph of size p or a independent set of size q. Okay. So is this concept clear?
Excuse me, sir.
Sorry, yeah.
Sir, in between a connection got cut. So, I have a doubt.
Yeah.
At 3, how is it 6? We can have 3 also, like 3 vertices.
Yeah, so
each
in
other
6
or
you have to
not
prove
connecting.
that. So I mean, it is more than 5, is it clear?
Sir, no, that part I did not get.
Sorry, you did not get the 5 part when it is more than 5?
Sir, it the voice got cut down and
No,
it
that's
was
fine. That's fine. I
bit
understand.
hazy.
But could you hear that part? At that
No.
that RPQ is strictly more than 5?
So that part only I did not get it.
Okay. So because consider this graph. So this graph is on 5 vertices. And in this graph, neither there is a triangle nor there is a 3 independent set. Okay. So
We can have a triangle by joining.
how do we have a triangle?
By
I can-
joining.
No, I'm not allowing you to join or not. That you don't have any power of that. Okay. See, your job is to find a triangle. Your job, all that you can tell me is that RPQ is that you can just fix in there. Okay, here is the number of vertices is 5. Now, as an adversary, I can go and draw the edges in whatever way I want.
Yes, so it can.
Yeah. So let's say I'll number them for you 1, 2, 3, 4, 5. Does it have a triangle?
We can join 1 and 3, 2 and 5, 1 and 4.
But
There's
you
a
are not allowed
triangle.
to join.
We are not allowed to join draw edges.
Yeah, you are not. See, idea is that I am an adversary and you are saying that, okay, see, here are 5 vertices, here are 5 people. Okay, so RPQ is, so what does mean? So what is it, if I tell you that RPQ is 5, what does this mean? What does this mean? What does this mean?
There are either 5 people who know each other or
No.
There are P people who know each other, Q people who know each other, and total 5 people are there.
No, the opposite of that. Okay, so it means for any 5 people. Okay, I am writing in bracket. Some may know each other, some of them know each other, and others don't know each other. Don't know each other. Okay, for any, this is important, for any 5 people, there exist either 3 people who basically forms a triangle, meaning they know each other, all of them. Okay, or there exist 3 people who don't know each other, like this as a whole. Okay, or in other words, I can write it in this following way, that any graph on 5 vertices, any graph on 5 vertices either has a triangle or a 3 independent set. Okay, is it clear?
Yes, sir.
Okay, now I am giving you this graph. This graph has 5 vertices.
Yes, sir.
Does it have a triangle?
No, sir.
Does it have an independent set, 3 independent set?
No, sir.
So that means this statement is not true.
Yes, but then, sir, in
That means that this is not 5.
Yes, sir.
Okay.
But then with 6 also we can draw a ring. With 7 also we can draw.
Okay,
a
let's
ring.
see. What about 6? If I change this one to 6, what happens after that? I can draw a 6 with ring. Does it have a triangle?
No, sir.
Does it have an independent set of size 3?
No.
No or yes?
Yes, sir.
Okay. So this graph is therefore not a counterexample to this statement.
Okay, sir. Understood.
Okay.
There is no, I mean, if we number it, then
There-
1, 3.
Here only you're showing, right?
Yes.
Yes, so there is an independent set. That's the thing. That's what I'm saying. Here there is an independent set. There is no triangle, that there is an independent set. So this statement is true for this graph, right? And what we have not proved it is that any graph on 6 vertices will have a triangle or an independent set of size 3. Any graph. Now this is not an easy thing to do. Okay, you can keep on drawing. You can keep on drawing things. Okay, and it's a pretty hard job to prove that RPQ equals to 3, like 6. So R33 equals to 6. Maybe if you want, you can try to prove it. That prove that R33. So what we have proved till now is R33 is strictly more than 5, but prove that R33 equals to 6. Meaning this statement, that any graph. So all I have told you is that this graph cannot be a counterexample to this statement, right? But you have to prove that R33 equals to 6. You have to prove that any graph will be able to, any graph on 6 vertices will have either a triangle or a 3.
Sir, if I have a path of 5 vertices, then I can I will not be having a triangle and will have a 3 independent set.
Correct. Right, I agree completely. If I have a path on 3 vertices, there are 3 independent sets. So So the triangle,
so the-
so this is not a counterexample to here. I agree. But just because one example is not a counterexample to a statement doesn't mean that it doesn't have a counterexample.
Okay.
Right?
Yeah. Right.
This is a counterexample to this. This is not a counterexample. I mean, this meaning with the
So
5.
using the CA, whatever in equation, we can use recursion.
Yeah, for the A it's not a recursion, it is a kind of a graph theoretic argument, okay? I mean, this
No,
is
I'm
a,
not talking about. I'm talking about using that in equation. We can do that. R33.
yes, using this 3A, you can prove 3B using recursion. Oh, you mean for R33? You can use
Not
it.
love that you discussed now.
No, okay, yeah, I mean, so, yeah, maybe you can use recursion to prove R3 equals to 6. Okay. Yeah, but by the way, I must say that this statement that is there, note that RPQ is less than this quantity, okay? But this is not tight. Very soon, I think you can prove that this number, that I think R34 or something, I think R34 is much lower than whatever is here. So this is just an upper bound on RPQ. It is not tight. So don't be surprised if this recurrence, 3, what does 3 gives you? 3 gives you 3 plus 3 6 minus 2 is 4. 4 choose 2 is 6. Okay, so this recurrence will give you R33 is 6. Yeah, so for R33, this recurrence will give you 6. Okay.
Sir, please scroll up once.
How far?
So that example where you showed 3, 2, R of 3, 2.
Oh, R of 2, 3. R of 2, 3 was, what did I do? R of 2, 3?
R of 3, 2.
R of 3, 2. R of 3, 2 was 3, I told, right?
But here, if we take the example where we do not draw any edge, then that will not follow.
But that is a Q2. That's a 2A. If I don't have any edge, right?
So here, yeah, no triangle and no independent set of 2.
Yes. So that means that a graph must have all of the edges to be there. If it doesn't have a Q2, Q equals to 2, that means all the edges are there. Because as soon as one edge is not there, that means you get an independent set of size 2. Right?
This is a counter example, sir, right?
Which is a counter example?
So this, when we do not draw any edge.
But this has the 2 thing.
So because the number of people who don't know each other is equal to 3.
So?
But it should be 2.
I don't understand.
So
Okay,
here
again,
we-
R32. What does R32 means? Let's write down what does R32 is.
That means 3 people.
R32 equals to
That
3.
means
What
3
does it
people
mean?
know each other, and
That
means if we take
for
3
any
people-
graph, okay, again, for all graphs, or maybe I should write, for any graph on 3 vertices, either there exists a triangle or an independent set of size 2. Okay?
Yes, sir, and now,
Yeah, so you are saying that this statement is not true.
and now if we take that graph,
Okay, this
without
graph.
edges,
Yeah, so tell me, does it have a triangle? No, right? Does it have an independent set of size 2? Hmm? Hello?
But here, yes, sir.
Does it have an independent set of size 2?
Yes, sir.
Then, if I am saying that either, right? It doesn't have to have both. Either it has a triangle or it has an independent set of size 2. So this graph has that. So this graph is not a counter example.
Sir, but according to the no, sir, but actually, according to the question, by definition of Ramsey,
yes,
so they are saying that the independent set should be exactly be equal to Q. Like there should be exactly the number of people who don't know each other. It's not mentioned that at least this much.
No. Again, by the way, there exists Q. Okay, so there exists Q of them who don't know each other. Doesn't mean that there doesn't exist Q plus 1 of them who don't know each other. Okay. I mean, there exists Q of them. If I say that in this class there exist 3 people who have scored 100 out of 100, or maybe I should not say that. Okay. So say that in this class there are 3 people who have got COVID. Doesn't mean that the fourth people have not got COVID. Right.
Actually, that means this is the minimum number of people.
It is always. I mean, this is how you say it, right? When you say that there are 3 people with something, that means that if there is a 4th people, I'm not saying that. I mean, yeah. So the minimum. I mean, at least Q number of them, if you can think of. Yeah. Okay.
Does that mean R32 is equal to 3 means we can say R32 is equal to 4, R32 is equal to 5?
So R32 is actually minimum of them. Okay, so I should not have written it like this. I should have written R32 is less than or equal to 3. Okay, so R32 is less than or equal to this. This is what it means. Okay, so an RQ5, look at this one. RPQ is defined to be the smallest integer n. Okay.
Greater than or equal to 3.
No, RPQ is RPQ is the smallest of them. Okay, so what did we prove? R33. Okay, so what we proved is that R33 must be more than 4. Because I found a counterexample. I proved that R33 must be more than 5 because I found a counterexample. So both of them have counterexamples. Okay. Now let's think of this way. Now this statement, okay? This statement is true for this to be equals to 6. Okay, this statement is also true. So now you can prove it actually. If this is true for 6, this is also true for 7. That means any graph on 7 vertices has a triangle or an independent set. Why? You give me any graph of 7 vertices, right? I can take one vertex and throw it away. So now what happens? I get a graph of 6 vertices. Right? In that 6 vertex thing, I should have a triangle or an independent set. Right? So I can also, I can keep on adding these numbers and it doesn't matter. Okay? So what is RPQ?
Then we should write R.
Yeah.
So then we should write R33 is greater than or equal to 6, right? That means R33 is always greater than or equal to 6.
Now what is R33? R33 is defined to be the smallest of these numbers. And do you see this, whatever is written there? So R33 is greater than or equal to 5. Okay. But R33, yes, you are right that if I take any number which is more than 6, then I will get it. Right? If I take a graph on 7 vertices, I will get it. If I get a graph on 8 vertices, I'll get it. If I take a graph on 100 vertices, I'll get it. Look at all the vertices, all the numbers for which I can guarantee you this statement. Okay. Say I can say that okay, this is maybe K. Okay. Any graph on K vertices either has a triangle or a 3 independent set. Consider all these Ks for which this statement is true. Okay, so this statement is not true for k equals 2. We know that this statement is not true for k equals to 4. This statement is not true for k equals to 5. But this statement is true for k equals to 6 and above. Okay. So R33 is determined to be the smallest of them. So smallest k such that, so it is the minimum over all the k's such that any graph on k vertices has a triangle or a 3 independent set. Okay, so this number does come out to be 6 for us. Is this clear? Ankit, are you confused?
Yes, sir. Yes.
Sir,
Yeah.
sir, how can R31 be equals to 1?
Okay, what is R31 means? What is R31?
Minimum number.
R31 equals to 1. Let's see, what does it mean, that statement?
A minimum number such that
Okay,
either
minimum number, right? Like it in the other direction, okay? That means any graph on one vertex has either a triangle or a independent set of size 1. Is this statement true or not?
Yes, sir.
Why is it true? Because it's the independent set of size 1. That means that's the vertex.
Okay, this will be always there, so we said that this is 1. Okay.
Right.
Yes, sir. Now clear.
Okay, so similarly R1Q is also 1. Okay, I think we have gone quite for a long, and maybe you guys have a class right now also, right? So I will stop now. We will meet again on Friday. I request again all those of you who are struggling, who did not understand this proof, at least when I asked you guys about whether you are following it and all, right? Can I please request you to send me a email? Please, please, please. Okay, this is something that is extremely important, so that we can accordingly talk to you guys and understand what is going on. Okay, and for the 20 of you who are not attending this class, I know that you are not listening to this thing, but if the people who are listening, if you can, please tell them the exactly same thing, that in case you are struggling, or if you are struggling on something, then please contact us. Even if they have internet issues, please ask them to contact us. We will see what can we do. Now, if they claim that I don't care, then that's fine. That's not much that I can do about it. Okay, please. I mean, this is a request. If you are unable to, I mean, communicate to us at least this much, whether you are struggling and you need some, it will be helpful to have some extra bit of assistance, then, I mean, I don't know, at this age, what can I do with you guys?
And sir, the assignment we can have the weekend, right?
Yes, you can have the weekend.
Yes, sir, because sir, Ramsey problem is stuck. So
that's fine. I will anyway discuss the Ramsey problem, at least the first part of it.
Okay.
To some level on Friday. But I will not be discussing the second part. The second part, you try to prove it by yourself.
Okay, sir.
Sir, actually in these slides, there are actually very few problems on I think there are no problems on 2-dimensional reduction. So if you can
Good.
do some practice problems.
Good what?
Around two-dimensional reduction, where we take two variables.
Yes, I agree completely, but this problem, although it looks like a two-dimensional stuff, it is not. Think about it.
No, sir, I'm telling that if you can do some practice problems
Yeah,
in
yeah,
class.
we will do that. Don't worry. The two-dimensional induction, if and when I get it, the thing that I kind of shared with you guys in the, which is there in the, which is there in, what is it called?
Course page.
Yeah, course page. Yeah, please take a look at that. That has a lot more information.
I think question number 5 is two-dimensional reduction.
Question number 5 is two-dimensional reduction.
Part B, I think.
Question number 5 is by no stretch a two-dimensional reduction.
So that's Fibonacci sequence.
No, it is not.
So part B also.
Part B is not a reduction itself, actually. It is more, it's not an induction thing. But anyways, try it out. And
okay.
Okay. ठीक है, चलो. Talk to you later. Hello, Nidhi.
Yes, sir.
See, again, if you think that you are understanding this stuff, then you don't have to write to me. But if you want to have a discussion and all, please write to us. We will only be able to help you if you kind of come to us.
Okay, sir.
Okay.